Let us move on to 1911 and the alpha scattering experiment of Ernst Rutherford, one of Thomson's students. Rutherford on the right and Thomson on the left worked together at Cambridge University in England. Rutherford's setup included a source of high-energy alpha particles, a stationary metal foil, and a detector to track down the alpha particles. Using an alpha ray gun, he shot alpha particles at a very thin piece of gold foil and noted where the particles went. Rutherford's experiment is a really good example of how scientists use the scientific method. Here's something you can do in class to drive the point home. Invite your students to imagine what the gold foil looks like at the atomic level. We could start by imagining a very thin piece of metal foil, a few layers of atoms thick, perhaps. If we use billiard balls to represent atoms, we see that they are very closely packed hard spheres. The gold foil is mostly solid atoms with just a bit of empty space where the spheres don't touch. What happens if you shoot high-energy particles at this? Does the gold foil disintegrate upon impact of the alpha particles? Because of their high energy, most of the alpha particles went through the gold foil. But about 1 in 8,000 were deflected or scattered, usually at small angles or less often backwards. No one was probably more surprised at the results of this experiment than Rutherford himself. He wrote at that time, "It was about as credible as if you had fired a 16-inch shell at a piece of tissue paper and it came back and hit you." How would you interpret these results?